Then subclaim D, as I mentioned before, is the other place where we really see these mathematical practices come out. And the PARCC folks feel that modeling is so important in mathematics that it should be assessed as its own kind of subclaim. It's as important as the reasoning, it's as important as the major and additional content in subclaims A and B. So you're going to see here, especially when you look excuse me, down at the bottom of this description for subclaim D, this is almost verbatim, those standards for mathematical practice. And so this is then, you know, the way that the vehicle through which students are going to demonstrate that use of mathematical practice. So the moral of the story is, if you only teach the content, if you only teach the stuff in A and B, your students will not be ready for this assessment. They will not be ready for the next grade level. They will not be good math thinkers. They will not be good math doers. So we have to couple the understanding in those subclaims A and B with this subclaim D, as well as C, certainly, which we just looked at. So let's look at the modeling a little bit and see if there are differences among the 3 grade levels. So this is the modeling for 6th grade, the first page. And again, as with the reasoning, I just want to point out, when you look at these standards that are keyed under here, these are not standards from the Common Core. These are specifications from the blueprints document. So again, get that blueprints document out, look at the subclaim D, and sit down with your assessments and your lesson plans and see, am I giving students the opportunity to apply mathematics in problems that are in life, that are in society, that are in the workplace. And what you see along here with the modeling in 6th grade is we're going from this simple use of stated assumptions to, you know, to make assumptions as I get higher and higher in my sophistication. And that has at its core this idea that students need to become more independent modelers and more independent problem solvers. And so you're going to give them a scenario where everything isn't laid out for them. And so they have to be able to describe what assumptions they're making, realize what impact those assumptions are making, from just identifying the important quantities to illustrating relationships. That's a level of sophistication that students won't have tomorrow. You know, we're not going to teach this today. Okay, today we're going to teach how to illustrate relationships. No. What we're going to do is gradually teach this over the course of the year, using that content to be the vehicle through which to teach the modeling. 7th grade, then, you see a very similar kind of, you know, description. That again, our goal here is to have students, you know, really go from this idea that I'm solving a word problem to really being given a mathematical scenario and then mapping out a viable solution method, a viable model, a viable analysis of relationships, writing complete expressions and equations and responses to this scenario, applying reasoning. So this subclaim D is kind of really where it all comes and gels together. So then again, when you look at grade 8, you see the same thing. And the point here is not that it's the same thing each grade level. There are components of that. But it's that we're doing this with our major and additional content. So what does it mean in 7th grade to make assumptions about some of those probability simulations versus in 8th grade make assumptions about some of my algebraic scenarios and rate of change and those kind of things. So what you want to do is sit down and see how this modeling permeates throughout your program regardless of your grade level. What you don't want to do is to sit down and say, okay, we did a unit on geometry, we did a unit on algebra, we did a unit on this and such, and now let's do a unit on modeling. No, Modeling and reasoning are those two things that are kind of like cross cutters, and they cut into every unit that you're going to do. Students will get better at it, certainly, as you go across the grades, but you don't wait for the end of the course to do the reasoning and the modeling. Okay, one more subclaim area, and this specifically applies to 6th grade teachers, because what's different with the PARCC assessments than with assessments you've had in the past is that the students are going to have to demonstrate fluency, and that's number sense fluency. And in 3rd, 4th, and 5th grade, they go from addition and subtraction fluency requirements to multiplication and division fluency requirements. So, and if you're interested, you can watch my previous webinar for those fluency sections toward the end of the webinar. But let's look for the 6th grade teachers about what the expectations are going to be. So in 6th grade, we are in the number system. And what we're asking students to do is basically, divide with accuracy, and then use all 4 operations with multi-digit decimals. Here we go. Multi-digit decimals appears in all of the levels. And so what you also then see is that as I go from level 2 to level 3, I do it more accurately. As I go from level 3 to level 4, I do it a little more quickly. And then as I go from level 4 to level 5, I'm not just doing it accurately and efficiently, we'll say, rather than quickly, but I'm also then assessing the reasonableness of my result. So it's not just enough to say that I'm fluent in this, 4 operations with multi-digit decimals, but then I know whether or not my answer makes sense. And so we need to give kids opportunities then to perform at that level 5 to then certainly prepare them for 7th and 8th grade, so that the focus of 7th and 8th grade moves on to the proportionality and the use of the algebra and geometry as well. Okay, so my goal for this session was to give you an overview of these performance level descriptors. Some things to think about as you go through this process is, okay, what do I do now? Well, a couple things. When you go through this webinar, you could stop at the end of sections A and B and just look at your grade level for content. Am I teaching this major content in a thorough way? Am I really making sure kids master it? Am I getting to that level in 4 and 5 performance or not? And I do that by looking at my assessments first. Are my assessments providing evidence that students are learning at that 4 and 5, at that level where they're truly prepared for the next grade level and for these assessments? Then you want to look at, okay, so as I plan for then the day-to-day interactions with students, are my discussions at such a level where I'm asking students to demonstrate evidence of their learning at that level? Or am I just asking kids for the right answers? Am I just ginning out problems to gin out problem, or am I truly having a discussion about why you chose that solution method? Maybe you might have to give them problems that have more than one solution method, and so on and so forth. Then certainly, lastly on there, is you want to take them and look at your lesson plans. Am I hitting on that major and additional content in the way that's rigorous, that's sophisticated? Once you do that for A and B and get the content in place, then I would go back, excuse me, and calibrate, and calibrate my assessments, my discussions, my lesson plans using that reasoning, subclaim C, and using that modeling, subclaim D, because that will then help me put the flesh on the bones of that content. And so as you go through this process, then what you'll come out with is a curriculum that really prepares students for rigorous learning and demonstration of learning of their mathematics. If you have any questions about this session, please email me at this address. And I will have a session on the high school performance level descriptors if you're interested, and then we will move away from the performance level descriptions for the next round of our sessions, and I'll send out the link for that sometime in December. Thank you so much for listening, and let me know if I can be of assistance.